Okay, this is going to be the first video about solving linear inequalities. And I'm going to spend just a super short time with a little introduction and then just going to jump into some examples. And hopefully after enough examples, things will kind of make sense. So just a super quick introduction. This is our greater than sign. So we have x is greater than y. And if we put a little line underneath our inequality sign here, we have x is greater than or equal to y. And then the same thing is true for less than. So x is less than y. You could also say y is greater than x. And then x is less than or equal to y. So just kind of the difference when you have a line underneath those signs versus not. And then one more thing, just super quick about graphing. So whenever we are trying to, so say we're trying to graph this inequality, x is greater than 2. If we don't have a line, if we don't have a x is greater than or equal to 2, we always use an open circle. So there's no line underneath our inequality. We want to graph with an open circle. So this means that 2 is not included in the solution for this inequality. So anything to the right of 2 is a solution to this inequality, but the number 2 itself is not. However, if we have a equals 2, so we have this little line, we use a closed circle or a filled in circle, meaning that 2 is included in the solution to this inequality here. If this doesn't make perfect sense, it's not that big of a deal, because after every single one of these inequalities that I'm going to solve, I'm going to graph it out, and hopefully after you see it enough times, you'll see what I mean by the difference between the closed and open circles, and you'll get pretty good at graphing these guys out. So here's our first example, and whenever I'm solving these, I'm pretty much just treating this inequality sign like it's an equal sign. The only difference is that if I multiply or divide by a negative number across this equal sign or across this inequality sign, I have to flip the direction of the sign. So if I have a sign that's looking something like this, I have to flip it to something like that. And the same thing goes if we include our equals, and we'll include our equals when we flip our sign. So I'm doing algebra, I'm doing everything the exact same as if I were that this were an equal sign. There's just kind of one extra thing that I need to keep track of in the back of my mind, and that is the flipping of the sign. So if I'm just treating this like an equal sign, and I want to solve for x, the first thing I want to do is I definitely want to bring that negative 2 into the parentheses, so we can break up these parentheses and then kind of begin to move things around. So this is going to be negative 2x minus 6, right? So we distributed that. And then all of this, it has to be less than or equal to 10. So I didn't multiply or divide by a negative across this sign, so it stays the same. I want to move my 6 over, so I'm going to add 6 to both sides. So when I add 6 to both sides, it cancels with this negative 6. So on my left-hand side, I get a negative 2x is less than or equal to, and I added 6 to both sides. So over here, we're going to have a 16. And then last but not least, I want to isolate x. I want to solve for x. So I'm going to divide this entire equation by negative 2, right? So we get our negative 2's to cancel here, and then over here on this side, we're just going to have 16 divided by negative 2. Now, I divided by a negative 2 across this sign, right? So that means that this sign needs to change directions. It needs to flip. So we have x is now greater than, and then 16 divided by negative 2 is negative 8. So that's going to be our final answer there. So again, this is just a simple algebra problem only instead of equal sign, we have this inequality sign. So we carry the inequality sign through just like we do the equal sign, only we need to change the direction if we do something like divide by a negative number or multiply by a negative number. So there's our solution there, and then I'm going to go ahead and graph this out. So pretty much I'm just going to draw a little number line here. I like to, when I draw my number lines, I like to kind of center them around the number that my solution includes. It kind of makes it a little bit easier to see. So this is going to be -8, right? Because this is the positive direction, and then in the negative direction, we're going to get more negative. So just a little sketch of the number line there. So we're going to be using a open circle, right? Since we don't have a line underneath our inequality there, we don't have x is greater than or equal to -8. We just have x has to be greater than -8. So we start at -8 and we want to do a open circle there. And then we want x to be greater than -8, right? So whenever we have a greater, we always want to shade in the positive direction. So we want to shade to the right. So that's going to look something just like that. So pretty much looking at our graph here, anything in this shaded region, so anything just after -8 and positive, so 0 or 10 or -6, is going to be a solution to our inequality equation. So we can plug that in here, and this will be a true statement. So there's our first example, and in the next couple videos we'll be doing plenty more examples of these along with the graph.